in section 4.2. And we are going to talk about special right triangles today and how they go along with what we are doing. So this is going to be 4.2 continued. And today is special right triangles. There are two of them. The first one, of course, is your 60-30 or 30-60. And I'm hoping the formulas she gave you were the short side is x, the hypotenuse was 2x, and the height was x square root 3. I'm hoping. Does it? Okay. Well, let me say it this way. On the front of the math portion of the SAT, this is how they write it. They give you this in your special right triangles, just like this. So I'm hoping that's how she taught you. The other one is a 45-45 triangle. And the formula for that one, if each of these sides are x, the hypotenuse is x square root 2. Hopefully those sound familiar. Now here's the deal. No matter what the length of the radius is, they're all going to increase at the same ratio, right? So what happens is when I'm doing sine, if I'm doing the sine of 60 degrees, I'm doing the opposite over hypotenuse. So I actually get x square root 3 over 2x. So no matter what x, they cancel. So the sine of 60 degrees is always, always, always square root 3 over 2. Okay? If I was doing the cosine at 60 degrees, that is adjacent over hypotenuse. And so no matter what x is, because they cancel, it's always 1/2. Okay? So it doesn't matter what the radius is. So we're going to change it just a little bit for you. All right? Oh, don't go that far. My bad. So if I were to say the sine at 45 degrees, I would go over to my 45-45 triangle, and sine is opposite over hypotenuse. My x's would cancel, and I get 1 over square root 2. No matter what size my x is, it always does that. Okay? And then that would rationalize, and we would get the square root 2 over 2. If I was doing the tangent at 45 degrees, so from 45, it's opposite over adjacent. So no matter what, the tangent of 45 is always what? 1, no matter what. Okay? If I were to do the cosine of 30 degrees, I would go to 30. It's adjacent over hypotenuse. What cancels here? The x's. And so it's always going to be square root 3 over 2. Okay? So if it is a special right triangle, it is always going to follow that pattern. All right? So we're actually going to change our special right triangles and just get rid of our x's here. It'll be much easier for you to use. So the real special right triangles that I want you to look at, let's see if I can get a good triangle written up here. All right. So if this is my 60-30, This side is going to be 1. The hypotenuse is always double that, so that's 2. And this side is square root 3. Because those x's are going to cancel. Okay? No matter what size it is, it all fits in that ratio. My second triangle is my 45-45 triangle. My right angle here. So if each of these sides are 1, the hypotenuse is square root 2. All right, we're all clear so far? Okay. Following that idea, we're going to leave that there, and we're going to start with talking about 19 through 24. Now, 30 degrees has another measurement that we're going to use more often. We have radian measure for 30 degrees, right? If we were to multiply 30 times pi over 180, we get pi over 6. So what is the radian measure for 60 degrees? Pi of 60, I'm going to times by pi over 180. What is my radian measure for 60 degrees? Yes, pi over 3, very good. On my 45-45 triangle, if I were to take 45 times pi over 180, we get pi over 4 in both corners. We're going to start thinking in radians. Now you'll notice, if you look back at my clock, starting at 0, my smallest measure you'll see there is pi over 6. Then we get the next one, pi over 4, pi over 3, and then pi over 2 is 90 degrees. It follows the same thing all the way around. So that clock is made up of nothing but special right triangles. So that's what we're going to be learning about. Okay? So, following this, example number 1, and what you are doing for 19 through 24. Evaluate without a calculator. So let's start by doing the cosine of pi over 3. So we go to our special right triangle, we go to pi over 3, and we do adjacent over hypotenuse. So what is it? 1 over 2. That's all you have to do. What if I gave you the cotangent of pi over 4? Cotangent, remember, is adjacent over opposite. It would just be 1, exactly. Let's do the sine of pi over 6. Remember that sine is opposite over hypotenuse. So from pi over 6, my opposite side is 1. My hypotenuse is 2. Do I have any questions so far? No questions? We're doing okay? Doing all right? Okay. Let's do one more. Let's take it a little bit tougher, and let's go cosecant at, I'm going to get a lot tougher. Let's go cosecant at pi over 6. That's not a lot tougher, but cosecant, remember, is hypotenuse over opposite. So from pi over 6, my hypotenuse is 2, my opposite is 1. So cosecant at pi over 6 is 2. Exactly. So you're referring to these two triangles all the time. Blake, you with us? We're good? Okay. So that's all you're doing is looking at these two triangles, finding those problems. Next section. Example number 2. for 25 through 28. Evaluate. Now, it says using a calculator, but then it says it wants the exact value. So it's easier just to use your right triangles. Okay? It says evaluate with an exact value. So first one I want to talk about is let's do the secant at 45 degrees. I'll go back to my triangle. Remember that secant is hypotenuse over adjacent. So in this one, if I have hypotenuse over adjacent, that is 2 over 1. Oh, sorry, square root 2 over 1. My bad. Square root 2 over 1, which is just square root 2. So again, you're just looking at your triangles for those four. Questions so far? Okay. Then you'll notice I skipped a bunch of problems up there, and I went to the next section, because then on Monday we're going to go back to those with the other section. Do you know what I mean? I'm going to kind of keep all of what you're doing together. So I'm going to rewrite our triangles up here real quick so we have them to refer to. All right. Okay, so in the next section, example number 3, we're going down to 41 through 48. And it says, find the acute angle for each of the functions. And so an example might be sine theta equals square root 3 over 2. So we've got to figure out what angle they're talking about. Okay? So obviously the triangle that has square root 3 in it and 2 in it is our 30/60, right? And so we've got to look at our angles and make sure this is opposite over hypotenuse. So which angle is opposite the square root 3? Correct. So this answer would be pi over 6 and 30 degrees. It does ask for both measurements, okay? Let's say I wanted the cosine theta equals 1/2. So again, that's on our first triangle, right? So, and cosine is adjacent. So what angle is adjacent to the 1? Yep. Oh, I wrote that wrong. Look at that. You said it right, and I wrote it wrong. Oh, my goodness. Sorry, guys. My bad. Yes, this one, opposite over hypotenuse, is pi over 3 and 60 degrees. And this one, adjacent over hypotenuse, is pi over 3 and 60 degrees. You said it right. I wrote it down wrong. All right. So let's try one a little bit tougher. How about the cosine theta of square root 2 over 2? So if you're looking at these two triangles, now this one's tougher because what happened is it got rationalized when it was there, right? If you look back to our first example, we did one where we had 1 over the square root of 2, and we rationalized it, okay? So what this really started off as Let me move that up a little bit. What this really started off as was 1 over the square root of 2. And remember that cosine is adjacent over hypotenuse. So what one does this triangle, or which triangle does this really go to? The 45, 45. So the angle for this would be pi over 4, or 45 degrees. We do just a couple more. You guys got questions? Anything I can, or you want to try some and see if we come up where our questions are? You guys tell me how you feeling about it. We're feeling pretty good? Okay, so we want to go ahead and try these questions, see where we're at, and we'll know what we need to clarify. Okay.